Welcome back to another episode. I remain your favorite tutor. Continuation from where we stop, simple harmonic motion. Today we'll be talking about energy of simple harmonic motion. We are going to consider two cases, pendulum bob and oscillating spring. Please, if you didn't get my previous video, you can always go back and get it. It's very simple. All right. The pendulum bob. Now, if this is the pendulum bob, if I extend this, I elongate it, let's just say I shift it to this end. If I release it, it's going to do what? Move. That is, it's going to oscillate, moving to and fro, observing what? Simple harmonic motion. Let's call here point A. Let's call here point B. This is the center position. Point C. See this. If I raise this body up, it moves, it starts to oscillate. Now, what are the energies here? The energy this body possesses at each point. If I take this body to this end, by virtue of its position, you know that from here to here, it will not be at the same level. If I take this body right here, it will not be at the same level. So it has what? Height. And we know that what? Potential energy depend on height, and kinetic energy depend on what? Speed. If I take this body to this position, there's a ground position, by virtue of its position, it possesses what? Potential energy, due to it have what? Height. So the energy right here is equal to the what? Potential what? Energy. Then if I let it go, you see that the height start to decrease. As decrease in height lead to what? Increase in what? Speed. Decrease in height lead to what? Increase in speed. It's just like when you sit down in that what? That's what they call that thing that normally go to and fro. Swing. If you, as soon as you extend it to a height, you let it go. See the way you move. Decrease in what? Height lead to what? Increase in what? Speed. That's what is happening here. As soon as the thing is going down, decreasing in height, the speed keep increasing. At this level, there is no height. Since there is no height, the energy possessed right here is what? Kinetic energy. That's the energy possessed right here, kinetic energy. As soon as it's going up right here, so therefore, the height is what? Increasing. The height is what? Increasing. So therefore, increase in speed lead to what? Decrease in, therefore, increase rather in height. The height starts to increase. Increase in height lead to what? Decrease in what? Speed. As soon as the body is going up, what is happening? The height is increasing and the speed is what? Decreasing. You get to a point that exhausts all its speed. And that point is what? Point B. It has exhausted all its what? Speed. It can no longer go further. So therefore, at this position, the energy it possesses is what? Potential energy. This is the same thing as what? Energy conservation. Mechanical conservation of what? Energy. It's just like conservation of mechanical energy. You know that in mechanical energy is divided into two parts, the potential and kinetic energy. This is energy conservation, whereby we say that what? The potential energy right here is converted to kinetic energy. Right here. So, if we say that the potential energy is converted to kinetic energy, so what is the potential energy? Or let's put it like this. Okay, what is the potential energy? That is mgh. What is the kinetic energy? 1/2 mv square. So let's look for the speed. So mass, we take away mass. So therefore, this is what? gh is equals to 1/2 v square. If I multiply both sides by 2, here times 2, here times what? 2. 2 we cancel out 2. So therefore, this is 2gh equals to what? V square. Take the square root of both sides. Let's switch it apart. This is v square equals to what? 2gh. Take the square root, so therefore v is equals to what? Square root 2gh. This is called what? The maximum what? Speed or maximum velocity in this case. Now this is what? Energy right here. Just take your time. You can pause the video, take it down. Let's go to the next case. All right, case 2. I'm going to wipe this board. You can always pause the video. Okay, case 2, we'll talk about what? Oscillating spring. Let's see. This is the what? Oscillating spring. This is the what? The mass of the spring. They call it, this is the what? The center position. That's the mean position. Mean position. Now, if I want this thing to oscillate, I want it to observe simple harmonic motion, I have to stretch it downwards. I have to extend this spring. So if I extend it, let us say it is right here now. The body is right here. So therefore, from here to here, the extension, let's call the extension Y. So I stretch it downwards. There is a force. If I release it, there is a force that will take it back. That force is called the restoring force. Taking it back to the mean position. And what is this restoring force? The restoring force right here is equals to what? Ky. You know where we get this from now? You know now. We have discussed this before. This is from Hooke's law. More reason you have to be on my YouTube channel. This is Hooke's law. I've done this countless times. If you are a student, make sure you are there. Please subscribe to my channel. It's going to help you. I swear it's going to help you. So this is Hooke's law. This is the Y is the word, the extension. The force is directly proportional to the what? To the extension. Now, the work done right here, the work done of an elastic spring is equals to 1/2 Fy in this case, or the same thing as what? 1/2 Ky square, which is the same thing as what? The elastic potential energy. Now this is the same thing as what? Elastic potential what? Energy. This, we have done this countless times. If you are just getting this video, just make sure like, subscribe, follow for more. We'll be dropping videos day to day. You don't have to miss anyone. Okay, now this is the elastic potential what? Energy. That's the energy the spring possesses right here. Energy of simple harmonic motion. Okay, now if we are looking for the total energy, let us say energy at maximum displacement. For energy at maximum displacement, or the total energy, let's say the total energy, let me put it right here. Total energy is equals to the energy at what? That is the energy at maximum displacement. Now you know that Y is just what? A displacement. Maximum displacement is what? Amplitude. Total energy is equals to what? That is the amplitude. Maximum displacement. That's the energy at maximum displacement, which is what? 1/2 K. Instead of using Y, we use what? A square. Now this is the what? The total energy. And the total energy of this body in motion, is equals to the kinetic energy, because since it is in motion, it's moving, it possesses kinetic energy, plus what? The elastic potential energy. The total energy of this body in motion is equals to what? The kinetic energy plus what? Elastic potential energy. And the total energy is what? 1/2 Ka square is equals to, kinetic energy is what? 1/2 mv squared plus what? Elastic potential energy is what? 1 over 2 ky squared. Can see. Now what we have to do is to make v subject formula. This v, that's the speed or velocity as the case may be. So from what we have here, we can look at this 1 over 2, 1 over 2, 1 over 2. Eliminate 1 over 2 from both sides. So what do we have? We have Ka squared equals to mv squared plus what? Ky squared. We are making this subject formula. If I take this to this other side, so this becomes what? That is Ka squared minus Ky squared equals to what? Mv squared. Okay, we are almost there. So right here, Kk, that's constant. Can easily bring it out. Is equals to K. Factorize this. That is a squared minus what? Y squared in bracket equals to what? Mv squared. Okay. Alright, we are making V subject formula. We divide both sides by mass. Divide both sides by mass. So mass cancel mass. So what do we have here? We have here that V is equals to, that is K over, let me write this thing very well. Then what? A squared minus Y squared in brackets. Sorry, this is V squared. Okay. We take the square root of both sides. That is V is equals to, that is square root of what? K over M. K over M bracket what? Then the square roots of this is A squared minus Y squared. Okay. Now, if this is the speed of this body observing simple harmonic motion, of this body in motion, if this is the speed, let's compare it with what? Speed at any point for normal simple harmonic motion. Let's compare. Compare it with the speed at any point. Speed at any point is what? Omega square roots. This is what? A square minus what? X square. This is what? Speed at any point. Remember, in this case, in the previous one, we use what? Radius square. Radius is the same thing as what? Amplitude. That is maximum displacement. So the same thing right here. A. So if we look at this, speed is equal to speed. See this? These two. They are equal to each other. Right here, this is displacement here. This is also displacement here. So therefore, I can say that what? The angular speed is equal to this. So therefore, omega is equal to square root K over what? M. And see, here we have it. And what is omega? Omega, which is the angular speed, is equal to, that is 2 pi over the period. 2 pi over period. So this is what? 2 pi over what? Period equals to square root of K over what? Square root of what? M. Okay. I take the inverse of both sides. I have it that what? Period over 2 pi is equals to what? That is square root of M over what? Square root of what? K. Taking inverse of both sides. Making period subject formula. Period is equals to, that is 2 pi, then square root M over what? K. So this is period for what? Oscillating spring. You can see how simple it is. Very simple. All right. Good news. We now have a lecture center in Benin City. And when you are coming, please come with all your problem. Come with all. We'll make sure we give you solutions to all your problems. We'll solve everything for you. All right, right there in Quest tutorial, we are having what? Classes for what? Science, arts, and social science. At number 1, Urubi Street, off Yaro, opposite Yoruba Street, just beside the waterboard, right there. That's where it is. Okay, in our next class, we are going to be solving problems. SSE problem, UTME problems, we'll be executing problem. Please stay tuned for more. And don't forget to subscribe to my YouTube channel. There you get to see all topics and many things on what? Physics and mathematics. I remain your favorite tutor. Thank you and God bless you.